Okay, everyone, so we're almost in the home stretch here. I do want to make the point, though, that first of all, for your assignment, you're going to have to document your process, which means you're going to actually write down the steps that you took and where you put what information and what columns you created and all of that. I'm going to give myself a hand here because I'm going to label these things. So I'm going to say difference from mean here, and here I'm going to say square of difference. And here I'm going to put something called the z-score. Now, the z-score is a score that is calculated with the use of the standard deviation. Okay, so again, if we refer back to our image here, and we see standard deviation. This is actually the one that we want, okay? So each of these little guys represents one standard deviation. Now, in a bell curve, okay, in a normally distributed data set, the meaning of a standard deviation is that we know that statistically we know that 68.27% of all of the values within the data set are going to fall within one standard deviation of the mean. And then we know that between 1 and 3 on either side is going to be another 15.73%, which means that over 99%, am I doing that math right? Yes, over 99% of our values are going to be between 0 and 3 standard deviations from the mean in both directions, right? So we're doing a two-tailed thing here, but basically the significance of that again is that if we find something that is has a z-score, so the sigmas are the z-score, right? It's the number of standard deviations, and if it's less than 3 or less than -3 or more than +3, we know that that value is a really unusual value for this data set. So again, all of this is in the service of understanding the context so that we understand how a particular value relates to the general values that we have. So the z-score is just how many standard deviations is a particular value from the mean. So all we need to do the z-score is we're going to take the value, okay, and we're just going to divide it by the standard deviation, okay? So again, in making this first one, I'm sorry, that's not quite correct. It's not the value itself, it's the distance from that value to the mean. So we're going to take its difference, right? So remember, this is how far is the value from the mean, okay? And we're going to divide it by the size of the standard deviation. And when we do that, we get the z-score, okay? So again, I'm gonna round these down. I'll give myself a single decimal place, right? But basically, that's the z-score is the number of standard deviations from the mean. So again, I'm going to need to lock in this reference. I want this to be F39, right? So that's so that it consistently refers to this particular cell, which has my standard deviation value in it. And once I've done that, I can just copy and fill this down the way, okay? So now what I can see is that actually, wait a second. Does that make sense to me? Yep, my mean is 584. So actually, you know, we only have this one score, right, that is actually pretty unusual. The rest of these are all well within range. Now, the other thing, and this is what we're going to address in a moment, or right now, is basically, well, is the mean and standard deviation a sensible way to describe this particular data set? And the way that we evaluate whether it's sensible is we actually just look at the shape. We can do a mathematical kind of inverse of this, and we'll look at doing that next week. But just to understand where this comes from, what we want to know is, you know, basically, is the shape of our distribution of values something like this, right? Is it symmetrical around the mean, or is it not? If it isn't symmetrical, we want to look at the median and the interquartile ranges and the upper bound and lower bound as our measure of central tendency and distribution and spread, I should say. If it is pretty symmetrical around the mean, then we can use the mean and the standard deviation. Okay, so there's two different measures of central tendency and spread that we look at, and it depends on the shape of the data set, the distribution of the data set. So what I'm going to do here is, in order to make this a little bit more meaningful, see, our measurements here are quite granular, right? This is number of seconds. So the way that we do this, the way that we look at the shape of this data is using a histogram. And a histogram is basically shows the number of times, it's a very special type of bar chart that shows the number of times that each particular value appears. Now the trick is that we have such granular values here that we're not going to get any value more than once, which means our histogram is going to be just flat, right? It's not really going to show us anything. So, again, too, like our interest in this measurement is probably not on the order of seconds, right? I probably don't, there's not a meaningful difference between 122 seconds and 121 seconds. I could probably look at something like minutes. So what I'm going to do is I'm going to take each of these and I'm going to divide it by 60, and I'm going to round it. And in fact, I don't actually, I'll go ahead and say round, right? So round is another function that's available, and I can actually, you can see here, it actually brought me up a little cheat, and I'm going to say 0 digits, right? So I want it to just give me whole minutes, and that should round in the way that we expect. So now what you can see is I actually do have some value repetitions here, right? I've got one ride that's 2 minutes, two that are 3, 3 that are 4, 2 that are 5, etc., etc. This is going to let me develop a histogram. And so what I'm going to do is just quickly translate this, and I'm going to use a little function. There's a very sort of basic charting function within Excel that's going to let me do this. It's going to let me look at this as though it were a bar, as though it were a histogram. So in order to do this, what I'm going to do is I'm going to take my values and I'm going to say min 2, okay, and I'm just going to create this for each of my values. 3, whoops, min 3. Now, the trick is actually, this is not quite as straightforward as it seems, because what I need to do is I need to make sure that I'm representing every individual possible value here, which means that I need, to go from 2 all the way up to 39 inclusive, but leave space for all of the things that aren't there. So the easiest way for me to do this, I'm going to show you all some tricks here. So the first is I am going to start with the number 2, okay? Now I'm going to do an equal sign. I'm going to say +1. That's going to give me 3. Now I'm going to stretch this down until I get to 39. So let's see if that's enough. Almost. Right? Okay, great. So now I am going to create labels out of this. And I'm going to say, that this label equals, okay, so concatenate is a function that joins together 2 strings, okay, so things that are surrounded in quotation marks. So I'm going to say min underscore is going to be the first part, right? I'm going to put that in quotation marks, plus, and then I'm going to select this thing. And, oh, like that. Yeah, I know you don't like that. Plus this. And hopefully, oh, it doesn't like that. Can I say string? Still doesn't like it. Well, goodness. I guess what we're going to have to do is this instead. Sorry. Take this. I'm going to use my other trick, which is paste as values. So I'm going to say copy, right click, paste special, values, and now they're just values. And now I'm going to change the formatting under format cells. I'm going to say these are text now. Okay, I've just asserted that. I've just said that's what they're going to be. Now I can use my concatenate formula to say min underscore plus. I know it seems silly, but plus. Oh no, it's because I keep doing the comma. There we go. All right. So here we go. And what I'm doing right now is I'm actually just constructing labels for my table. And now what I have to do is enter the number of times each of these values appears. So 2 appears once, right? 3 appears twice. 4 appears 3 times. 5 appears twice. 6 appears how many times? 6 times. 7 appears twice. 8 appears twice. 9 appears 3 times. 10 appears twice. 11 appears once. Nothing for 12, 13, or 14. I get 15 once, I get 16 once, and then I get nothing until 23, which appears once, and then I have 36 and 39. Okay, so what you'll see is we can obviously tell a lot of these are zeros. Oops, that's a 0, and that's a 1. Phew, okay, now we have the data we need for our histogram. So again, we're gonna use this for our histogram. So I'm just gonna select all of my data points here, and I'm going to say insert. Oh no, that's wrong. I'm going to come up to, so I've selected charts here. I'm going to choose column, clustered column. It's not really clustered. And now we see here the distribution of our data. So what we see actually is that this is definitely skewed, right? Our most common value by far is a 6-minute ride. Okay, and actually it's relatively symmetric around that. You know, we can see how it goes up and down. And then we have like we have this tail, right? So what this tells us is that we would want to use the median as the measurement here and the IQR as the evaluation for what is unusual, right? Because we do have these outliers to longer trips, but mostly we're pretty strongly clustered around 10 minutes, under 10 minutes. So what we can see from this is basically that our real outliers here, even though by our mean distribution, and again, we can see how the mean can be skewed by these outliers, right? According to our z-score, which is here, only this last value is an outlier. But actually, if we look at it, we would assess that through the IQR, this 997, that we have at least these 3 that are outliers, these 3 right here. Okay, these are going to be our unusual trips. The 23, 36, and 39 are all pretty extreme for this particular time period. So that is the sort of guts of our contextual analysis that we use. And so again, we might then start to look into the things that are unusual about this. So typically when we're looking for patterns, which we're going to begin to do more of next week, what we're looking for are usually things that are trends, right? So things that lots of people do or that are very common, or things that are unique, things that only happen occasionally. And through pursuing those and reporting those out, we can learn more about the data and how the data relates to the world. And that, at its heart, is the essence of data journalism. If you have any questions, be sure to post them to Piazza. And other than that, we will pick up again next week.